Welcome to my second podcast on separable differential equations. So the problem we're going to tackle today looks difficult, but it's really not. At least I hope not. And this is supposed to be an x. So let me fix that. Here we go. So as I said earlier, in separable differential equations, the whole idea is to get all of the x variables along with the differential on one side and all of the y variables along with the differential on the other side. So this is pretty easily accomplished by doing it like this. Now, the left side and the right side are now separated into their variables, and so this is what I want to integrate. And so I want to think of the left side as y to the negative 1/2 power. Okay? So maybe I'll just write that out just so we see exactly what's going on here. So this is really y to the negative 1/2 power dy. And over here, I'm going to pull the 4 out, and I've just really got ln of x over x dx. So when I do the integral, I can see that this is just 2y to the 1/2 power. But the other side's a little more subtle, because that probably would require integration by substitution. So to do that integration by substitution, I'm going to just do a little bit of work off to the side really quickly here, and I'm going to let u equal ln of x. Therefore, du is equal to 1 over x dx. And so what I really have over here is just the simple integral 4 times u du. And so that's really the integral that I'm doing. And so when I finish this off, it's going to be 4 times u squared over 2 plus c. But I think I'd like to put back the x, the x term. And so in the end, I've really got 2y to the 1/2 power equals 4 over 2, which I guess I could simplify, and maybe that's what I'll do now. So I'll simplify that to be just 2 times ln of x squared plus c. So I'm going to go ahead and erase this work now, because we don't really need this anymore since we took care of that integral. So at this point, we've actually solved for kind of a general solution, but we probably need to now use the initial condition to really finish this out and get a nice answer. So we do know that the point that we want to use is when x equals e, y should equal 1. And so maybe this time we'll just go ahead and plug that in and try to solve for c right off the bat. So when we plug that in, here I'll use purple again. So when we plug that all in, we've got 2 times 1 to the 1/2 power is equal to 2 times ln of e, quantity squared, plus c. So what do we see here? Well, we see pretty quickly that the left side is equal to 2, and the right side is equal to 2 plus c. So clearly, c needs to equal 0. So our equation suddenly turns into 2y to the 1/2 power equals 2 times the quantity, ln of x, squared, because the plus c is no longer necessary since c is equal to 0. Now we're going to reduce out the 2's, since we've got one on both sides. And then what we're going to do is we're going to square both sides. And so when we square both sides, we get that y is equal to ln of x to the 4th power.